Hi everyone, in this lecture we will talk about generators in Python. So, generators are special type of functions that allow for generating a sequence of values over time, and their behavior is much like an iterator. And the main advantage of generators is that instead of creating and returning the entire sequence all at once, generators return one value at a time and wait until the next value is called. And they are defined like a normal function. But instead of return keyword, generators use yield keyword. Both yield and return keywords return some values, but the difference is that return keyword terminates the entire function execution after returning the data, while yield statement passes the function execution and saves all its states. And if function is called again, it continues from there on. So if I describe the whole picture in one line, generators are iterable functions, simply. So, without further discussion, let's understand generators in more detail with the help of examples. So, I have created a new Python file with the name generators.py, as you can see here. And we know that generators are functions. So, let's define here a simple function, def, and I'll name it gen. And for now we will not pass any kind of parameter and just put colon. And now in the body of this generator, let's define a variable with the name a, and let's assign value of 10. And I have told you that in generators we use yield keyword instead of return keyword, and wherever you see a yield keyword in a function, this means that it's not a simple function, it's a generator. So just write here yield in order to tell the Python interpreter that it's not a simple function, it's a generator, and I'll return this a. Let's save it. Now generators act like an iterator. So I'll save all the iterable objects which this generator will return in this it variable, and I'll say it is equals to gen. Okay, and now let's print this it, and let's print the type as well. So just type here print type and it. Let's save it, and now let's run it. And here we go. First of all, we got the object location, and then we got the generator class. Now this function belongs to a generator class because of this yield keyword. This yield keyword is telling the Python interpreter that it's not a function, it's a generator. And now if it's a generator, this means that it will behave like an iterator, and in order to get values from an iterator we use the next keyword. So let me remove it, and now I'll say item is equals to next next, and then pass the object of the generator which is it. And we have discussed this next function in the previous iterator lecture, and that's why I have told you in that lecture that the sole purpose of discussing iterator is to understand the concept of generators. And now let's print this item, print item. Let's save it, and now you will see that the Python will print the value of a. Let's run it, and we got the value of a. So I hope that you have understood that how generators act like iterators. First of all, we need to instantiate, or we need to fetch all the iterable objects of this generator function in a variable, and here we have declared the variable with the name it, and then we are accessing the values of this it with the help of this next function. And in the beginning of this lecture, I have told you that yield does not terminate the execution of a function. So let's declare here another variable with the name b is equals to maybe 20. And now let's yield this b as well. So let's write here yield yield and then b. Let's save it, and let's run this Python file again. And we got 10 right here. But what if I say print next and then it? So we are calling this iterable object one more time. So let's save it, let's run it, and now we got 10 and 20. So the concept of generators and iterators is same. In iterators, calling the next function multiple times print the data items one by one, and same is the case with the generators. But here we need to write this yield in order to tell the Python interpreter that if user call this function again, just throw this value. And if I call this next function the third time, obviously we will get error. So let's save it, let's run it, and we got stop iteration error. And the reason is that this generator is generating only two values, a and b. But if I write here maybe c is equals to 3 and then d is equals to 6, and let's yield c, and then just right here yield d. Let's save it and let's run it now, and we got 10, then 20, and then 3 because of this c yield. And we can call this next function one more time because this generator is generating 4 values. So let's copy this line, paste it right here, let's save it, let's run it. Okay, so we got 6. So before I actually end this lecture, let me tell you that generally we use generators in data analysis because these generators are memory efficient functions, and in analysis we have hundreds and thousands of data, and it becomes nearly impossible to save all the data in the memory before performing actions. So to overcome this issue, we use generators instead of simple functions due to their capability of optimizing memory space. And in the next lecture, we will discuss some more examples regarding generators, and I'll see you there. Bye bye.